This is the review/preview of Friday's class. So on Friday, we're going to start looking at integers. And the first thing we're going to be doing with integers is we're going to be looking at this particular way of communicating and thinking about integers. So this is a model for integers. I don't know if I want to say of or for. So a model is a way of representing something that's a mathematical concept. So this model that we're going to use is our weights and floats model. So what we need is we need something that is going to go up and down when we attach some weight to it to make it go down, or attach something buoyant to make it go up. So this is going to be our standard picture for today, but I bet you can think of some other cases where you might have something that would move, that you could attach something to move it up, or attach something else to make it move down. So we've got a boat here, and we're going to take our boat and we are going to say, all right, this boat floats at some standard level. So we pick something that's a standard level to be our zero here. This is our home level. We'll think of this as the water level, but it could be the height of the dock. Whatever you want to pick as your standard base level, that's your zero. And then if I attach a weight to it, so these weights look like anchors, then that weight is going to weigh it down, and it's going to go down a little bit in the water. And we're going to put some markers here on the water. So I'm going to put some marks here at units. So this is 1 unit below, and I'm going to call that -1. And 2 units below water level, and I'm going to call that -2. 3 units below, I'm going to call that -3. And of course, if I take a weight off, then my boat is going to be buoyed up, and it's going to sit higher in the water. And then I've got these floaty things, and so I'm going to imagine that it's possible to attach those floaty things to my boat in such a way as to make it more buoyant and to go up higher. So I attach one floaty thing, so I'm going to imagine that that makes me go up 1 unit. And of course my units could be feet or inches or centimeters. Whatever makes most sense for your model. And we're going to suppose that our weights and our floats are equally balanced. So that means that if I have a boat, and my boat is floating around here with a weight and a float attached to it, that evens out. And if I have just a float, that goes up 1 unit. And if I have just a weight, it's going down a unit. And so those are kind of equally, they do equal and opposite, have an equal and opposite effect. Equal distance, opposite direction effect on what the boat does. And so you're gonna do in class on Friday, we will be doing / we did some example problems with what happens when you take a boat and you attach some weights and some floats to it, and think about what's going to happen to the boat. That boat isn't going to move, because having a weight and a float balances out. Having a weight and a float balances out. So those are called zero pairs because they have zero effect on where the boat is. All right, so having that pair on there is equivalent to having nothing on there, right? So the boat is going to be in the same place whether I have a zero pair or whether I don't. And so if I have a boat that starts off at the standard depth, I don't know how many weights and floats are attached to it. Except, of course, I know that I have an equal number of weights and floats. I don't have more weights and I don't have more floats. And so I can ask questions about a boat that starts off at its standard sea level, and then you put on some extra weights, or you take off some weights. And you might put on an extra float, or you might take off some floats. And I just pulled the wrong thing. So there I've taken off a float, there I've taken off a float, etc. So that's our model. And that is what you need to have in your brain when you go to do the Desmos activity that's assigned.